Okay, that is camera roll 56. Sleep one.
One of the things I sort of like to do is ask a question which loosens people up, but it's quite a serious question. And I'm not a scientist. Most people outside watching are not scientists. And there seems now to be almost a holy language evolving, the language of mathematics, which in a way is separating a very few of them from a very large number of us. What do you think about that, and what could we do about that?
Yes, well, that's a question that's concerned me for a long time, because I'm in physics, of course, but even as early as the late 1940s, when people were returning from the war, I saw that there was a tendency to believe that mathematics was the essential point about physics, and concepts and intuitive notions were not that important. And I found that very disturbing. And that tendency has grown. You see, people say that unless you have an equation, you have nothing to talk about. It's as if your contact with the world were through equations. And in some ways that comes about because the experiments in physics now are very large and abstract and distant contacts anyway, so you don't really have a sensory contact with the world. And therefore the equation seems to be the thing they're talking about now. That's a kind of idea that has grown up. And at that time I felt I thought of trying to develop a view in which we would say the mathematics was one side and the concepts were another. They should be interwoven. But I think I wrote a book, a quantum theory, on that basis, but which was well received. But nevertheless, the general tendency has gone that way. Now, I think it's part of the science community. It's part of the spirit of the age. Right?
But now I've read a number of things that you've written, a number of things other people have written, and there are certain concepts which it seems almost impossible to say in any other way except mathematics. And that maybe, are those concepts likely to increase?
Which concepts do you have one in mind?
Well, I'm talking about quantum theory, for instance.
Well, yeah, I've been developing an idea of the implicate order, enfolded order. I think many of the concepts of quantum theory can be put, but in non-technical terms. But I think that there's a big resistance in the physics community to doing this unless it produces some new results. You see, I developed another interpretation of the quantum theory, which I had then called the Causal Interpretation, but people said it gave no new results. It was just another way of looking at it. They were not interested now. In other words, the idea now is that people are interested in equations predicting experimental results, so you can't break into it unless you can do that.
And is there any, do you see a change happening? Do you see a change in say, the education system whereby the non-specialist would be able to understand something as difficult as quantum?
Well, it's not happening now. I think it could be done, you see. But in fact, in some ways, the concepts of quantum theory that I'm developing may come closer to ordinary experience than classical physics does. But I think that there's a tremendous momentum behind the development of the past 50 or 100 years, which will change, cannot be rapidly changed.
Could we go on to really the first question that the first general question we were concerned with, and that was the fact that maybe the new physics has fundamentally altered the way in which we conceive of reality. Could you talk a little bit about that?
Yes, well, if you probably mean by the new physics, relativity and quantum theory, well, I have my way of looking at it. I say that they show that reality is an undivided whole. It is not that the notion of breaking things up into separate parts which just interact is not adequate. Now, that actually relativity, for example, says the world is an undivided whole, it would say basically all is one as a field spread out through space, and even what we call a particle is a region of concentrated field that stays together and moves as a unit, and it spreads out and merges with another particle and so on. So in reality we don't have that much those particles anymore. And now in quantum theory you have a much more thoroughgoing wholeness, which would, I could say has three features. One, the quantum process is supposed to be indivisible, an elementary process. And it's as if every step were a link which cannot be divided. So in principle the universe cannot be divided. But we can make an approximate division because there are so many links. And like many grains of sand appear to be continuous now. So on the large scale, the ordinary idea is recovered, where you can approximately separate. Then the second point is you have this wave-particle duality. An electron behaves both like a wave and a particle, and a typical experiment is this, that we have an interference experiment, two slits, which you may have heard of. Now, the electrons are passed through those slits. Now, they show an interference pattern. Now, if this were a wave, we could understand it, because waves from going through one slit could cancel the waves from another slit at certain points, producing no effect, and they'd add in another place and produce fringes. But the electrons always so it looks as if the electron came in as a particle and spread out into a wave and then became a particle again. Now, this behavior seems so mysterious that people like Niels Bohr said that there was no way to understand it intuitively at all. You could only calculate the probabilities. Right? Now there's the third point was the non-locality, namely an action at a distance. That we find that particles in certain circumstances can apparently act on each other at long distances, directly faster than light, although we can't use it to transmit a signal.
Is this Bell's theorem?
Well, that's what Bell's theorem is concerned with. Shall we discuss that?
I'd love to discuss Bell's theorem. Do you think Bell's theorem is important, or is that a very silly question?
Well, it is important, yes. I mean, you want to discuss it now?
It seems to naturally lead on from
yes. Now, well, let me say that Bell's theorem, really it began when I gave a seminar in University College in London in 1957. He was a student in the audience. Now, I gave my interpretation of the quantum theory, which gave an explanation of how it worked, where according to all what had been said, this was impossible. So Bell was very struck by this. He became very interested in the question, and he wanted to get a more precise mathematical expression for a general rule for when was it possible to have what we call a local causal explanation, namely by things touching each other, or near each other, right? Or spreading, connected by waves that spread out. And he worked out his criterion for certain experimental results that would have to be satisfied in order for you to have a local causal explanation. And he showed immediately quantum theory doesn't satisfy the criterion, showing that quantum theory does not have a local causal explanation. And since that time, many experiments have been done, culminating in the work of Aspect, who showed in more detail that in fact the experiments also back this up, right? So therefore, we say either two things, that one of two things are possible. Either there is a non-local causal explanation, or there is no explanation. Now, most physicists have said, we don't care, there's no explanation. It doesn't bother us. So, go ahead.
That's fine.
$57. Stand by. Slate number 2.
So, perhaps you'd like to go on and develop this.
Yes. The question of local versus non-local, or action in contact or action at a distance, was an old one in physics. Newton raised it, And he had people asked him, how does gravity work? It looks as if there's action at a distance, and he was very dissatisfied with that idea, you see, at least on one. And later people got the idea of a field that would explain it, right? Connecting the particles to something distant, right? But a field that would fall off and get weaker and weaker as you got further away. Now, this quantum action at a distance doesn't always fall off, you see. In fact, it may be the full intensity far away, but a certain small probability of the full intensity. So, also, it's, as far as we could tell, instantaneous, so it would violate relativity. Now, Einstein...
if I may interrupt there, it means that a particle which is 7 billion miles away, in our terms, from another particle, might be able to seemingly communicate with another particle.
Yeah, this would have only a small probability, but it could happen. It wouldn't. Yeah, it would not be a communication that we could use to carry a signal. Now,
that's a mysterious saying.
well, no, we can show that to carry a signal, you must, like in a radio wave, put a definite form on the wave, and you can see that if you try to put this form on, you can't do it. That the wave is not that controllable, right? So so relativity would not be violated as far as experiments that we can now do are concerned, but in principle, the underlying structure would not be relativistic. And of course, Einstein felt very fundamentally that action at a distance was a wrong idea. He called it spooky. You see, he didn't want to have this sort of mysterious sort of thing.
Do you think that there is a division, really, between... Is Einstein at the division between, say, what we might call the new paradigm, what I might, in my ignorance, call the new paradigm, and the old paradigm?
Yeah. No, I don't think... We don't have a new paradigm yet. You see, people talk about it, but there isn't one. You see, it depends on how you use the word paradigm. Now, the way Thomas Kuhn meant was that it was a sort of a general set of concepts which were accepted by most people, and practices and things they would pick up as an apprenticeship in graduate school and so on, subliminally. And we have a few people who are suggesting new ideas. The paradigm would only come if the majority of physicists were to take them up and were to be teaching them in graduate school and writing papers about them and so on.
Could you, I know you must have done this so many times, but could you give me a sort of short version of what shall we say, some of the new ideas might be that would be put under a basket called a new paradigm?
Well, just what we've been talking about. You see, there would be this non-locality, the wholeness. These would be the essential new ideas, you see, that are quite contrary to the whole trend of physics for, say, since Newton until the early 20th century.
What, again, it's very difficult for those who have lived with the notion that you cut the world up and you describe it as in bits and pieces, to think how one would use a language and a thought.
Yeah, well,
when do you think we started cutting the world up?
Well, probably some analysis was always there, but you see, it gradually increased, and then came the idea that it could all be analyzed. Everybody uses analysis, it cuts things up, but for various purposes. But the idea came that everything could be understood that way. Now, it was in principle present in the atomic theory of Democritus, say the ancient Greeks. But it was not really carried forward until more modern times, and with Newton's law and so on, and with more modern knowledge, you could take the atoms more seriously.
So it would be Bacon, probably, that one might...
Well, I wouldn't even say Bacon. It's hard, you can't point. I mean, I'd say Descartes is the man who I would say is the really key figure. You know, he developed his coordinate system, you know, his grid, which was the ideal way of analyzing the world, and separated mind and matter.
The interesting thing, I think, is why a thing catches on. You know, is there something in the air? Is there a need for a system to be there?
Well, I think that around that time of Newton and Descartes, it was in the air. There was a developing industry and commerce which could use this idea very well, and I've also read it was it combined. It sort of was a nice compromise between science and religion. You see, the scientists wanted to get rid of interference from religion. The religious people were having trouble with pantheism and all sorts of ideas in the Middle Ages of matter being alive, and they didn't like it. You see, so at that time, and they worked it out nicely because they were really both scientists and religious people were working more or less on the same direction. And they said the very simple idea that the universe is mechanical. It's the business of scientists to deal with it. And God made it. But it either runs by itself or else it needs occasional repair in the form of miracles. But therefore the business of spirit is religion. You see, mind and spirit, right? Everything is a machine, including animals and whatnot. Only man's immortal soul is not. Religion deals with that. So that was specialization. They divided the world into two specialties. And of course, the religious people lost the whole thing that way because gradually science spread out and encroached on their domain, saying, where is this immortal soul? Where is God? There's no place for any of it. So.
Now, are we at a point where there may be different needs and therefore a different paradigm might actually arise?
Well, I think as far as physics is concerned, if you want to understand it, you have got to change your approach. If you're satisfied to calculate, you don't have to change it at all, of course.
But do you see any signs around you, not just in physics, but do you see any signs around you in the world?
Well, I see a lot of signs in the world at large that people are thinking about this, many people, and suggesting it outside of physics. I think many people outside of physics would welcome this, but physicists at the present moment are generally holding on.
Okay, let's cut that a second.
Slate 3.
If there's just to go back on what we were talking about before, as to whether you see any signs and symbols, as it were, of a need for an implicate order, if you like.
In what context? I mean.
I mean, for instance, we see a lot of international meetings.
Oh yes.
We see we see astronauts going out and sitting on the moon. Instead of looking out that way, they look back and they see this little blue ball, and suddenly the ecology movement is born. I mean, I'm oversimplifying the effect.
Yes, well, I think that there is a growing movement in society today, a growing need for a new approach with wholeness. I think people are sensing that this fragmentation is inadequate. And there are conferences like the one we're having here in Amsterdam, and where science, art, and spirituality and economics are brought together. There have been similar conferences, but in addition, as you said, we've got the ecology movement where clearly we have got to start looking at ourselves differently, looking at the world. We have to see it as one world, and we have to see ourselves as emerging out of this world and being sustained by the world and falling back in. It is not an environment surrounding us, but it is our ground of existence.
We also keep talking about we have to do this and we have to do the other. And I often wonder if I'd said this 15 years ago, I'd have been booted out and told that I was a silly hippie or something. But that there may be some other form of intelligence, if you like, or systemic work which is going on, which is forcing us to do something.
Well, it's hard to say that. I mean, I think that the growing awareness of the crisis is enough explanation that it takes time for this to penetrate, and it becomes more and more evident. At first, people said it's only a few odd people who are projecting this crisis, but everything looks all right wherever you look. But then they begin to see it isn't all right, like all these photographs of the Amazon and pollution everywhere. There's so many, I mean, I say the BBC is putting on a vast number of programs of that kind. I think books come out, and I think there's green parties developing it. It's a sign of a spreading awareness.
But do you think it's only spreading from us, or, I mean, you imply, forgive the pun, but you imply in your work a sort of deeper and deeper order, amounting to what we might call determinism.
Well, I wouldn't call it that, but still.
Well, what would you call it?
Well, a creative order.
Could you expand a little bit on that?
Yes. Well, you see, determinism was a view that came out about the time of Newton, and Laplace suggested. See, they said if all the particles in the universe had determined positions of momentum, then everything could be predicted, right, from then on, forever. And Laplace said, you know, if you had a demon who could know all that, could calculate it all, he would know everything. Now, that was complete determinism. Now, then there was a reaction against that in the 20th century in favor of chance, you see, which is the other side.
On slate number 4. Yes, absolutely. Hold on. 54 head mark.
So I was mumbling and bumbling about determinism, and you were telling me about Laplace and his...
Yes, well, after Newton, some century or so after, Laplace came, a great mathematician, and he said, if you know the initial positions and velocities of all the particles in the universe, you could predict everything forever. And he imagined a demon who could know all this. And then, you know, when Napoleon, I think, asked him, you know, what does he think of God? And he said he has no need of that hypothesis, right? So it shows the whole change of spirit, right? I mean, how the religious people made a serious mistake.
I can't just, I mean, do you have any need of that hypothesis?
Well, it depends. For what, I'm not making the hypothesis, no. But I meant that there's a tremendous change in a rather short time, comparatively short time now, which has now become common, you see. And well, during the 19th century, determinism prevailed, but during the 20th century, with quantum theory, there came the idea of the opposite, absolute indeterminism, chance, right? And then the regularities on a large scale were merely the result of chance, right? Large numbers. Now, I would take a view which is somewhere in between, you see. There's an order between determinism and indeterminism. To understand that, I think we have to broaden the question. It's not just determinism, but to necessity. And determinism is a form of necessity. And necessity is what cannot be otherwise. Right?
Could you give me, if you can, an example of that?
Well, determinism is a case that you say it's got to be this way, right? Now, but I give other examples. You see, necessity could also, its deeper meaning, be what cannot be turned aside. And you could say like a big storm cannot be turned aside. You know, a certain big thing, you know, things happen and death cannot be turned aside, various things. And if the government, generally the individual cannot make the government turn aside. Maybe a bigger government can. And so we have an order of necessities, you see, which one turns aside for which. But then we make it the view of absolute necessity, which, you know, is just so, right? Nothing. It's just nothing. Everything must turn aside for that. And God would have been thought of as absolute necessity, the will of God. But then that was replaced in physics by the laws of nature were taken as absolute necessity. So they're equivalent to the will of God. The very word law, you must ask who legislated it. You see, it's a poor word without somebody to legislate it. And they could say it's a regularity, but then that does not suggest absolute necessity. Therefore, the laws could be limited and could change, right? New laws could be found. The old laws are limiting cases. So I take the view that nature is inexhaustible. There's no limit to this law. And now we have, see, where necessity. Now we have contingency. What can be otherwise, what can be turned aside, but contingencies are made necessary by conditions, right? But they can change, right? Now, but I say everything is eventually a contingency in a broad enough context, right? But a whole mass of contingencies makes up a new necessity. You see, as in statistics, or many streams coming to make a big river. but the river turns to contingency when it goes over the rapids. So there's an interweaving of necessity and contingency, in my view, in the whole set of what we may call laws, but regularities, whatever, within nature. And we had an extreme case of it in classical physics. We thought of absolute necessity, of determinism. And now quantum mechanics talks of the absolute necessity of chance. But I say these are extremes, right? It's a contradiction almost to talk of the absolute necessity of contingency. So.
Not the sort of phrase one uses in the club. How did your work? What was the point where you felt that you were on the right track and you were heading for the work you're doing now?
Well, I don't know exactly where. You see, I started out, writing a book on quantum theory where I tried to explain Bohr's point of view, and when I finished, I felt I hadn't understood it that well. I began to think again, and I had two ideas, you see. Well, the first idea was that you had a wave coming in. You see, a quantum theory, a typical experiment is an electron comes in and scatters off a particle. And you think of it as a wave coming in and scattering, but then you still detect a particle, you see, so how does that come about? So I said, there's a second wave coming in from infinity to where you detect the particle. But then that suggests that spreads out, and then it becomes a third wave and a fourth wave. So you have a whole series. The particle is not an actually solid object, but a series of steps very close to each other, a dynamic process. Now that was really the germ of the implicate order, the universe unfolding into that particle and then folding back, and doing it again and again in a similar way.
Did you think of this because you thought about it from some other stimulus other than mathematics, or did it come out of mathematics?
It was an attempt to explain the mathematics, but the idea must come from a more general experience, clearly.
Is that normal, you think, for physicists?
Well, it always has been normal, yes. I mean, I think that things have gotten so abstract now that I can't say what people are doing exactly and what gives them the ideas now, but certainly until this more modern era, it was the normal way.
Are we now at a point where there's, well, for instance, Everett's many worlds theory, and so on and so forth. Are we at a point where reality has to be redefined, if that's a...
Well, that's a deep question. You see, what do you mean by the word reality? You see now, but it's interesting, the root of reality of Latin, it means, res means thing, and it comes from a verb, rari, R-E-R-I, meaning to think, you see. It's the thing that you think about. So realities are things which you have to grasp in your thought as well as by your hand, right? Now, I think that the notions of reality have changed constantly going back to prehistoric times and on. Clearly, the Australian Aborigines and other such people had a very different idea of reality. And it's developing. Each age seems to think its idea of reality is the right one, but I don't accept that. You see, there are many possible ideas about reality now. So I would like to give a view of it, which make that clear. Now,
Mark number 5.
So, you were talking about reality.
And yes, I would like to explain my views of reality by an example. You see, here we have right there a circular table, solid, but it really looks like an ellipse on your eye. Any artist would draw it as an ellipse, right? If you went to the other side, it would be a different ellipse. There are a whole series of ellipses which are related because they reveal the same table. So we say that the appearance is an ellipse and the essence, the true being, is a circular table. So that's a view. But then the scientists have said that's not so at all because it's made of atoms, mostly empty space. So the table also is an appearance, a circle, but the atoms are supposed to be the true being, essence. But then they came along and said atoms are made of electrons and protons and so on, and atoms also are mostly empty space. And the appearances, and obviously they're appearances to the mind, right? Not to your senses. But see, in other words, thought gives appearances, right? Now then, but even the electrons and protons were made of smaller particles and quarks, and these are made up of fields, as Einstein suggested. I suggest it could go on forever, that there will be no final theory. And that, in other words, we have a kind of a situation where what was the essence at one level becomes an appearance as we go deeper. And that it's really, what counts is everything is appearance and everything is essence, but the many, many appearances, all coherently interrelated, are pointing to reality, guiding us. We may call them correct appearances up to a point. Now, appearances may be incorrect and mislead you, or they may be illusory. So obviously, the fact that there is this distinction shows that it's not arbitrary what you call a correct appearance, right? There is something in relation to the unknown reality, but we cannot say. You see, the reality itself underlying this cannot be grasped in thought, right? Because thought can only give appearances.
But we agree, I mean, when I say we in the West,
yeah,
sort of agree that that's a table, and it's probably a round table.
Up to a point, but the physicists would say it's a collection of atoms, mostly empty space. It fades off into the surrounding. Depending on our context, we have a different view of the reality.
However, there's a very large context in which a large number of people would say that was a table.
I agree. That's so. That's what I'm saying too. That the appearance is a correct appearance, as I said.
There are some tribes, however, shall we say, some tribal cultures, where they do have a rather different view of the reality than we in the West have. Do you think that's a valuable thing to explore?
Well, yes, I should think it is, but I think we in the West have changed our view of reality over the past 1,000 years radically. 2,000 or 3,000 years ago, it may have been closer to these other more tribes, primitive people, as you call them. Our views of reality are constantly changing, you see, and they will change again. In a century from now, people may call our own present views naive, right?
But for instance, are we ever likely, Dr. Bohm, to be able to think in 4 dimensions or 5 dimensions?
Well,
in other words, are we limited? Is there a reality which is limited in here somewhere?
There's some, we don't know what the limits are. You see, whether we can transcend them in some way. You see, that in some sense, I think we always have a multidimensional perception of reality. And that 3 dimensions is a particular way that the eye has organized it. But artists, for example, explore something more multidimensional. And I think that the implicate order is multidimensional. In other words, the imagination can grasp multidimensionality in other ways. Right?
Could you talk a little bit more? You must be tired of doing it, but could you talk a little bit more about the implicate order?
Yes. Well, see, I began to explain that, and
I cut you off. I'm sorry.
Yeah. Now, later on, I came to the idea in the '60s more definitely, and we can take there 2 examples of the implicate order means enfolded order. Now, an example of enfoldment, a very simple example, is to fold up a piece of paper many, many times and make a few cuts in it. When you unfold it, you see a pattern, right? The idea is that somehow the things that we see in front of us, which I call explicate or unfolded, are the unfoldment of a deeper pattern that is not visible. Now, there are several examples. One is the holograph, and another, that's probably the easiest example, that everybody has seen these holographic images, and you have a laser of making highly coherent light, all in order, and it's split into two beams. One goes to an object and one goes straight on. And the light hits the object and reflects off. It comes back to interfere with the original beam, making a pattern very fine and nothing visible. And you can photograph that. And then you shine laser light through it again, and you see a three-dimensional object. The waves come off as if from the original. But the main point that I want to emphasize is that each part of the hologram in principle contains information about the whole object, whereas with a photograph made by a lens, you aim for having each part of the photograph giving information only about a corresponding part of the object, right? So the lens is really a device that analyzes. The holograph does not analyze, right? It contains the information about the whole. Now, my suggestion was, and then suppose we remove the photograph and go back to the interference pattern. That is a movement. So that movement contains information about the whole object, movement of waves. And if we are in this room, all the waves coming to the eyeball, to the retina of the eye, to the pupil of the eye contain information about the room. They unfold onto the retina, and then from there somehow back into the brain, and you get consciousness of the room, right? The same may be true of the whole universe when you look at night in the sky, or with a telescope. So the idea is that everything is constantly unfolded and unfolding in a dynamic process. Now, my suggestion was that quantum theory could be understood, its mathematics and so on, if you said the basic reality was to be thought of, called the essence for this purpose, was to be thought of as a movement of folding and unfolding, and that the things that appear to us are the result of that, right? Now, therefore, the electron is constantly folding and unfolding. You see the part, everything, and now that means you have a kind of wholeness, because the whole universe is present in everything, but not present not only passively but actively.
Now, actively, where does the pattern come from? The pattern comes from the molecules back?
No, it comes from the unknown. It's the whole universe. I say there's the whole of movement. See, in this view, we say the atoms are appearances, just as physics is saying anyway. Ultimately, this too might be an appearance, but we say at each stage we're accepting something as the essence to explain the rest. It's a way of thought that we have adopted. Right?
What does that say, if anything at all, about our notion, for instance, of ethics? Or is there, if you have an order which is, and in some way we are a pattern, then what does it say about the ethics of the moment?
Yes, well, it suggests that our consciousness, for example, unfolds the whole universe at each moment actively, because what we do depends on what's there, right, the content. And including not only what's there now, but the past as recorded. Right? The whole past is in there too, right? It suggests that ethics, which treats each person as separate, has no meaning. In other words, ethics is not there because God told you he wants you to be nice, but rather that makes no sense to be otherwise. Because everybody ultimately is everything and everybody. You see, he does not exist as a separate unit on the underlying level, right? It's approximately so only.
I'm going to stop here, Kat. And I wanted to just...
Camera roll 60, sound 32. So hit mark number 7.
I was saying before, when you were talking about individual and about ethics, that this might be a dangerous situation.
In what way?
Well, the fact that you have, you talked about ethics being something which changes, which is something we impose, and therefore if you have something which has a predeterminism to it, or an order to it, or a pattern, doesn't it give too much freedom to those who believe they know what reality is?
Well, there is a danger in any ethics, whether, you know...
I'm sorry, I beg your pardon.
See, I think that ethics has this inherent difficulty in that if you make it absolute, it's arbitrary, it becomes dangerous, and if you make it relative, it's dangerous. And anyway, even if you say everything is relative, that is an absolute statement, again, a contradiction. So we appear to be in a difficult situation there. Now, I think there's nothing that can replace clarity. You see, if people are not clear, if they're incoherent and confused, then whatever you say is not going to work. And that in fact has been the situation in the human race, that people have been very unclear about ethics. So I think we have to say our first priority is clarity.
How do you know when something's clear? Because there was a point at which it was clear that Newton's world and his mechanics thing, and then it was clear that something else, then it was clear.
Yeah, you have to be constantly sensitive to incoherence. You see, I think people are always pushing out. So they should have said not that it's clear that this is Newton's world, but rather this fits what we know. You see, they simply said too much. You see, that's the way it is, right? If they had said, well, it's clear that the evidence we have fits this idea, that would have been right. And now, therefore, the tendency to become absolute, to go too far and say it covers everything.
So the theory of the day helps to solve the problems of the day?
Yes, well, up to a point. It may go beyond that day, but not cover everything. So, in fact, a good theory carries you much further, but still doesn't cover the whole. Say the whole cannot be grasped in thought. There's some sense of the whole which cannot be put in words. And we have to move from that, you see.
I just worry about when people talk about, I mean, I have a very privileged life. I go around the world talking to people and doing the things I really want to do and so on. And yet I feel very stupid. Now, how much more stupid do other people feel who don't have my privileged life? And when somebody talks about, there are 26 dimensions we're now working on, you think, wait a second, what does that mean?
Well, who knows? I think that's a hypothesis. You see, just like Laplace said about God. So people thought God was important, and now many people think less important. So some people felt in the string theory that this had a certain importance, but string theory has many problems in it. It hasn't solved everything. It's a hypothesis that if you start with these 26 dimensions, then you can do some nice mathematics which will sort of explain some things. That's all there is to it, right? It doesn't. We're not missing much by not understanding it. You see, because very few physicists understand that. It's very difficult mathematics. I don't really understand. I get a general idea what they're doing, but I would have to devote years to find out what they're doing, right?
Something very funny about having a general idea about 26 dimensions. At the end of one of the interviews, a recent interview, you said that you were talking about a common consciousness. Could you talk a little bit about that? Because you then went on to say that maybe we may have a new kind of intelligence.
Yes. Yes, well, I think intelligence is the key even to the previous question you raised about ethics. Without intelligence, there can be no real ethics. Right? And now I was saying that in the context of my ideas on dialogue. The notion of dialogue, not just simply exchange and trade-off and negotiation, but something deeper. Now, the root dialogos in Greek would suggest a flow of meaning among people. Now, I like to give this example of the North American Indian tribe I read about many, many years ago. It's stuck in my mind. An anthropologist visited them, and he said they regularly frequently anyway, would sit in a circle. There were probably 30, 40 people there. They're hunter-gatherers. And they would just talk and talk and talk with no agenda, no purpose, and make no decisions, and it just seemed to stop at an arbitrary point. But then they all knew what to do. You see, they understood each other, right? Now that's the kind of common consciousness I have in mind. I think that early man had it for 1 million years. And since we developed big, complicated societies with authority and people competing and trying to get to the top, and fear and all those things, they don't trust each other, and the whole thing broke up, right? Whereas in that simple situation, everybody could trust everybody, and so on. Now, I think that, but I think that we could work on it now, and this common consciousness has meant this dialogue requires a lot of discussion, but one key point is that everybody has got various fundamental assumptions and opinions about what's necessary, right? And what's necessary is not merely a thought, it's a feeling, it drives you, an urge, and so on. It affects everything, right? Now, if you could suspend those opinions, which means not only hold them on a knife edge between defending them and carrying them out or suppressing them, so suspended in front of you and everybody else to look at, everybody. We would say everybody's opinions are on the same footing. Mine, yours, so on. See, an opinion is basically not important. It's only an assumption. Why should we defend it? Why should we identify with it? So if we all look at our opinions together, our assumptions, and our basic, then we will have a common content of consciousness. At present, everybody defends his opinion. Well, it's not merely he defends it, but he tends to defend it against evidence that it may be wrong. You see, now that is an incoherent procedure, which is counterproductive. Right? And so if we had this common consciousness, we would be able to do two things. You see, to think together, which means not that we are trying to convince each other or anything, but rather some person would have an idea, it would pass to another, to another, to another. The entire pool of the group, the intelligence of the group would be available. And there would be a common feeling. You see, we could call it impersonal fellowship, a sense of participation. And I think that that did exist for this million years, and it was lost as soon as we got into large-scale civilization.
It's going to be very difficult to do that, isn't it? I mean, doesn't one need a tribal structure? I mean, you yourself are saying you sort of need a tribal structure.
Well, not necessarily. You see, we have to explore. You see, we mustn't make assumptions of necessity because they'll trap us, right? If you say we need this, that's an assumption. Now, that could mean it's impossible, but the impossibility may arise from the assumption. Right? That's why you have to watch the assumptions. Now, the point is, what we're suggesting is that we could just get together groups of 20 to 40 and see if we can do it. Not for the purpose of establishing a group, but for the purpose of exploring communication, right? And if we could, this might be a germ. You would, you see, I say culture is shared meaning, which is now incoherent. But if we could do this, we would have a kind of, see, in the beginning this group is a microcosm of the whole culture with all its diversity, and, well, not merely diversity, but all its incoherence.
Millennium in Amsterdam.
You were talking about the use of groups.
Yes.
So perhaps you'd like to go on with it.
Yes. Well, you see, I think that if we make a group like this, it starts out as a microcosm of our society, and you will have in it all the problems, you know, people fighting over their opinions and defending their egos and so on. And you have to work through it. I think it takes a certain amount of knowledge and skill, somebody, a facilitator, to help. People who just arbitrarily try this are not likely to succeed. And but I think you can get through it. It would take sustained work, sometimes as much as maybe a year. You see, regularly once a week.
What does this? And you're now talking about literally a sort of almost tribes of interest, well, coming together of interest.
Well, no, they don't have to. We would have a variegated group who would have. They would be interested in dialogue. You see, we would say, why are they in dialogue? Because they see the significance of it, they see the value of it, and therefore they form the purpose. It's not to impose a purpose, but if these people can see the significance and value, then they will have the purpose, right? They will stick with it. Anybody who wants to do anything difficult has to go through difficulties and stick with it, right?
Does this do anything to the representative process as we use it?
Well, we won't start there at all. You see, we're saying it's at the grassroots. You see, to reach that would take a long time because there are many more interests there, you see. I think that we have got to establish a change of consciousness at the base, you see, which will filter upwards, not downwards.
Right. How do you do that? Do you start at the age of 5 or 2? I mean, is there
any age.
mechanism?
I think, I don't know whether children would do it, but they won't do it if the adults don't do it. You see, they take their cue from the adults. So the adults have got to do it. They can't start if they can't do it, you see. So they've got to get together. We can't think of education until the educators themselves have a different consciousness, right? And that's creative process.
Does that lead to a new form of intelligence? I mean, is the danger that it might lead to a sort of ant-like form of intelligence?
No, because in this dialogue we're not imposing. You see, every person may have his opinion. We just simply share our opinions. You see, there's no pressure to hold a common opinion. We're not trying to do anything. This is crucial. It's an empty space. You see, we say when the time comes to do something, these principles will be working, as with the North American Indians. But here we are creating an empty space for the sake of exploring communication because it has really broken down.
Do you think what is called the explosion in information, is that helping? Or is it
well,
a sign of the time?
It works both ways. You see that it obviously creates a vast flood of misinformation too, which is in the way, but in principle it could help, to spread these things, right?
How do you keep, is it difficult to keep your identity in this?
No, you don't worry about it. You see, you're not under any pressure. You're free, right? You don't try to hold on to your identity or try to get rid of it. See, that's a side issue. We are really trying to communicate. See, I like to give the example of the first people who climbed Mount Everest. Not that I think it was a great, wonderful thing to do, but in order to do it, they had to go through all sorts of things with great energy, and if they hadn't sustained it, they would not have done it. You see, now, I don't think they were thinking of identity or non-identity or anything like that. They were thinking, we want to get to the top of the mountain, right?
They were thinking outside of themselves.
Yeah, but beyond themselves is better, because we have to think inside and outside.
Do you think that society at the moment is tending to be somewhat introspective? Individually introspective?
Well, probably so. I mean, many people are, yes. Many people are not. But you see, introspection, introversion and extroversion are a side issue. You see, I think that whether you look inwardly or outwardly, you will see the same incoherence. And
Slide number 9.
One of the things which has sort of come in from the outside, which is a very central concept of your work, is the definition of coherence.
Yeah.
Talk a little bit.
Yeah, the word coherence literally means to hold together, and the coherence we can sort of sense by order, harmony, beauty, and so on. But the main point is to sense incoherence. And when we walk into a room, we may feel something is out of place, and then just a feeling, and then we look and see what is it, and so on. Now, you see, I think the principal problem of the human species is incoherence of the process of thought, and its activity and what comes out of it. And in other words, the main sign of incoherence is that you do not get the results you intend. Right? And the contradiction and confusion and conflict are particular cases of it, right?
Does that apply to art as well?
Well, yes, in incoherence in art, you would not see it hold together, you see. You see, however chaotic it may look, if to be a real work of art, it should in some sense hold together.
Jackson Pollock would be
Yes. I mean, I remember a friend of mine said he first went to see Jackson Pollock and he wasn't impressed. He said, I'll go home and I'll do the same thing. And he tried many times and he got nowhere.
He said he was an incoherent painter.
Well, he had not, see, Pollock had the thing under perfect order, right? So all this apparent chaos was part of a greater coherence. Right? Now, see, so Now, there are many, many examples. You see, we want peace and we get war, you see. We want to have a nice earth to live on, but we produce destruction of the earth, you know. And another example, people didn't want to have this war in the Middle East, but they sent in vast amounts of arms, which made it possible. You can multiply examples of incoherence by any amount, and that's counterproductive, you see, and it causes suffering. And I think it's inherent in thought that thought tends to produce incoherence the way we're working it now, because we are not very clear about what we're doing, you see. And I'm not saying that we should get perfect coherence. We'll never get that, but we have to have an attitude of moving toward coherence when we see incoherence. But if we have an attitude of defending incoherence, then that will be very destructive, you see. And I think you will see that people generally do find themselves defending their incoherence.
And your notion of dialogue, the sort of dialogue we just discussed, is a way in which coherence will become apparent.
Well, incoherence will first become apparent. That's why it can be an unpleasant process, which you've got to stick to. That's why I brought in Mount Everest. You see, but coherence will come out. You see now. If I take the example of the laser, ordinary light is incoherent. It moves in all directions, and in the laser, it's all moving together in phase and does new things that ordinary light can't do. And a coherent mind in one person could do more than an incoherent mind, but a coherent mind among 20, 30 people could do much more, right?
May burn a hole in the universe.
Well, it would burn a hole in our present social arrangements, I think. Because it would expose the incoherence as so glaringly obvious that something might happen.
Okay. Colleagues and I call in my markers. If they put money into it, it goes on.
Well, they won't waste any money, that's sure.
I'd just like to go over one thing, and that is, do you feel your work has anything to do with, or is the connection with, what I'm told is the emerging science of chaos?
Yes, well, I think there is a connection. You see, the chaos theory really begins with the fact that even very simple systems are highly unstable, so that the slightest change of conditions changes the result over the long run, and you can't predict them or control them. But from there you see that in what we call chaos is a very complex pattern of order, which I say is in some ways parallel, similar to the implicate order, that there is enfolded there an order which unfolds as it goes along. And I think the implicate order, that chaos theory is a particular kind of the implicate order, I would say.
So if we take any particular moment in time or space or both, then it's almost like a sort of snapshot of the unfoldment.
Yes, yes, and see, the simplest example of fractals is to have a triangle and then make a smaller triangle on each one and then a smaller one and so on. So it's self-similar, you continue the pattern, right? Now the implicate order also has another kind of self-similarity, that something unfolds and then the next stage unfolds self-similar but different and so on, you see.
But basically you can't, in the implicate order and in chaos, are you saying you always have to have elephants all the way down?
Well, no, because it can change. Even chaos theory, they have already worked with random variations, and you could change it, enrich it in countless ways. They've merely taken the simplest orders so far.
What about turbulence and things like strange attractors and those phrases that capture the imagination?
Well, what about what?
Well, does this have anything to do with the implicate order, with enfoldment?
Well, not all that directly. I mean, it probably has, but that's more directed at particular kinds of movement that go on in large-scale systems. The strange attractors do work, in my view of quantum theory, that what we call, see, one of the problems in quantum theory, see, which led to the idea of the indivisible jump of the quantum of action, was that an electron would go from one orbit to another apparently without passing in between. Now, I say that what happens is that there's an unfoldment, and folds again into the next level. So now, in the mathematics of that, you have things like attractors and strange attractors, that each stable orbit is a kind of attractor.
So there is a point in the unfoldment where it is a critical moment.
Yes.
At that point, we're talking about an attractor.
Yes. See, there is a common theme in there.
Do we know that through the mathematics, or do we know that in any way through experiment?
Well, it's primarily through the mathematics. You see, the experiment would be impossible to do in quantum mechanics because it would disturb the system too much, or even in hydrodynamics, whatever you do disturbs it. Like saying a small change in what you do about the weather will disturb it a week or two later.
Dr. Bohm, is there anything you would like to add? I mean, is there anything that you think is important for science to say at the moment? I mean, without spending 4 hours doing it.
Well, in what context, I mean?
Well, I presume when you go to one of these conferences, you go there with the idea that you're going to engage in dialogue, and that dialogue is going to, in some way, affect the future of thinking, or the future of physics, or maybe even the future of the world.
Well, it's a contribution. I mean, I'd say that if there is dialogue, then it's a part of the process. I mean, I hope that we don't always begin without much dialogue, but I think that dialogue develops, and the longer time, the better chance we have for it. And I think, well, I would just say one point, that one of the most difficult points about dialogue is to have a dialogue among scientists, because the reason is very simple, that scientists tend to think of their views as truth, and therefore there's nothing really to dialogue about. You don't think of suspending your assumptions. So I've always had the fantasy of a dialogue among scientists, if we could establish that. And then going on from there, we ought to have a dialogue of these science, art, and spirituality, which would be even harder. But But I think that would be a kind of dialogue which would would begin the change of our culture.